So, hi everyone. My name is Theodore. I'm currently working as a software engineer in a company called Workable, and I'm living in Athens, Greece. And today I'm super excited because I have the chance to present you one of the most interesting ideas that I have ever had the chance to work with. So today I'm going to show you how you can actually prototype a device that mix and matches JavaScript and the very basic principles of IoT. Before we start, though, it's really important to take a step back and have a look how our community has evolved over the past few years. As a matter of fact, we can feel extremely blessed because our community has gained so much traction and attention, and we can actually speak beyond code about things that actually matter, like accessibility, and accessibility is one of them. But what accessibility is all about? So if we take a look at the dictionary term of accessibility, we will find out that accessibility refers to all these actions we have to take in order to create products, environments, or services accessible to everyone. And someone could say that the term itself is a bit vague and has applications in different scientific fields, from engineering to architecture. But as far as we're concerned, though, as software engineers, web developers, or web designers, we are mostly focused into creating accessible communication systems. So we are integrating assistive software with our applications, creating accessible communication systems, establishing accessible communication channels with our end users. You will be fairly surprised, though, if I tell you that the very first accessible communication system is nearly 200 years old. This is Louis Braille. Braille was born and raised in a small city outside of Paris in the early 19th century. As a child, he suffered a terrible accident that left him completely blind for both his eyes. But still, he has mastered his disability, excelled his education, and finally got accepted in the National School for Blind Youth in Paris. It was back then where he found out that the reading and writing system used by visually impaired people back in the days was a bit absurd. So people were trying to recreate the sighted alphabet using ink and fat brushstrokes. So Braille committed himself into the cause of bridging the communication gap between the blind and the sighted. At the age of 15, he introduced the famous Braille system. So Braille is a tactile system. We can also say that it is the very first binary communication system ever made. So in Braille, characters, symbols, or letters are getting encoded using combinations of raised dots and spaces. Each character, as you can see, its character has raised the dots and spaces, and the users can trace down the letters using their fingertips. So they can recognize the letters or symbols, also known as Braille cells, trace down each letter, creating words, sentences, and so on. And Braille system was good. It was actually so good that hasn't literally changed since its birth. Nowadays, it is translated in more than 200 languages, and we can find applications from math to music composition and so on. Soon after Braille's death, his system got widely adopted, and soon after, publishers started publishing books in Braille using heavyweight paper and embossed typesets. Also, in the early 20th century, typewriters were invented. Modified Braille typewriters provided the users with a semi-automatic way of writing Braille. By the way, the happy typing lady you can see in the video using the Braille type letter is Helen Keller. Helen Keller was a famous American author, an activist about human rights for people with disabilities, and also the very first blind deaf person that has managed to graduate college. Finally, our last piece in our puzzle was introduced in the late 1980s, early 1990s. These retro-looking devices are called refreshable Braille displays. As you can see, the device on the bottom has a fixed set of Braille cells. So the users can pair these devices with external hardware or software And using this device, they can browse through Braille text more easily. So let's recap. The year is 2019. Organizations and individuals are raising awareness about literacy rates all around the globe. We have the tools, we have the assets, we have a system that actually works for so long. So Common could say that we're in a really good shape, right? We're actually wrong. Numbers and statistics are heartbreaking. As we speak, there are nearly 253 million people living with visual impairment all around the globe. Most of them are suffering poverty or living within war zones. And just 10% of them have some sort of access to proper educational material, to Braille books or services, or even a chance to get a job. And someone could say that we cannot relate with these numbers, right? Most of us, we're here in Ireland, we're living in high-end societies, we have proper educational and healthcare systems. Bear with me for a moment. According to the National Federation of the Blind of the United States, nearly 90% of Americans' blind children have no prior access to any sort of Braille educational material. Just to give a perspective about how low these numbers are, I'm going to compare them against the literacy rates of Ethiopia, a country that has suffered civil war for more than 15 years, and it's one of the poorest countries in Africa. So in Ethiopia, nearly 50% of people are capable of reading and writing. And as we speak, these numbers are increasing. On the other hand, Braille literacy rates are stuck since the 70s. And we have to think ourselves, what did we do so wrong? So what's actually causing that problem? As a matter of fact, Braille just needs practice. We have to have some sort of book or in order to read or write. Books in Braille are like super expensive. Their cost 6 to 8 times higher than a regular book. And just 1% of any book available is also available in Braille. Braille displays are like super expensive. They cost from $500 to $8,000 each. And since the marketplace is so niche, there are just a few companies developing this hardware, and there's no such thing as research and development. And finally, typewriters are super expensive as well. And although the technology is a bit obsolete, people are still using them as it's a more affordable way of writing. And now imagine that someone hands you this problem and tells you, hey, is there anything we can do about this problem? Is there anything as a community that we can do? So we're going to try and build a prototype, a device that could actually help us teach ourselves Braille. We're going to try to mimic how refreshable Braille displays work, maybe starting small, like using a single Braille cell and expanding as we go on. And before we start, it's really important to set up some goals. First thing first, since I had no prior experience with hardware, I wanted to make this device as simple to build as possible. No exotic components, no sophisticated software and so on. Also, obviously, we need to make this device as accessible as possible. And finally, our main goal is to make it as cheap as possible. But how can we get started? So is it actually doable prototyping hardware these days? For the purpose of this experiment, we're going to accelerate our development process using a piece of technology called microcontrollers. So microcontrollers are like tiny computational units, easy to purchase, hack, or writing software for them. Arduinos, Raspberry Pis, Node MCU, Esperinos, just to name a few. For the purpose of this example, we're going to stick with one of the most famous ones. This is an Arduino Uno. And as you can see, there are like pins popping out from the board, so we can use these pins and attach external components or hardware in order to expand the capabilities of the board. So since we want to get immediately started, we're going to try to develop a hello world of hardware engineering, something like flashing an LED. So we have attached an LED The one leg of the LED is attached to the pin labeled 13th, and the other one is attached to the ground just to power up the LED. And the Arduino comes with an IDE called the Arduino IDE, and we are using C in order to program it. So a piece of code that flashes the LED would look like this. First things first, we're going to allocate the pin labeled 13th as an output. And finally, using an infinite loop called loop, we're going to flash the LED with an interval of 500 milliseconds. And this example works. But as I was trying and experimenting with different modules or trying to make this device work with web interfaces, I found myself stuck. And I have to be honest with you, I haven't written C since my college years, so it was a really hard time for me. But luckily, though, I found a project called Johnny 5. So Johnny 5 is a platform IDE developed by a Canadian company called Workable. It's open source. And it allows us to write code using Node.js for microcontrollers. So we can either execute the code directly on the board, or we can use, in our case, use Johnny 5 in order to remotely control the board. So in our case, we're going to use Johnny 5 controlling the Arduino with a protocol called firm data. Rewriting the previous example, first things first, we're going to include the Johnny 5 module. We're going to create a new board. And when the board is ready using a callback, we're going to instantiate a new LED instance and flash the LED. And I can barely hear some of you whispering, what's wrong with this guy? Why does he want to run JavaScript on a microcontroller? C works great, right? And the thing is that JavaScript feels way too natural. So if you want to get yourself into the IoT world, you will find yourself handling events all the time, clicks, flashing lights, and so on. And JavaScript was built for event-driven programming. Also, we can use the registry. So if you want the utility function, you can use load-us. You can actually enrich your IoT experiences using WebRTC, the Bluetooth API, everything that's up in the registry. Also, we can run the same code, the same code targeting different devices, and that's really important because even within the same family, different boards have different hardware and software specifications. So the Arduino Uno is totally different from the Arduino Nano and so on. And finally, we have to admit that hacking JavaScript lives within our DNA. 2 years ago in NodeConf, I have witnessed a project where JavaScript was running on an NES console. We can run JavaScript on smartwatches, apparently, on badges, on mobile phones. And this is what powers up this community. Finally, next up, I was troubled and I was trying to create a 3D design. So this is how a Braille cell looks like. As you can see, the enclosure is made from plastic and the pins are inside, so we can actually create Braille cells in order to attach or detach extensive Braille cells on demand. And during this process, I used my 3D printer, and I was able to create iterations where I was evaluating its component. And finally, we have to tackle down another problem. How are we going to actually pop up a pin? How we can translate data, Braille data, into motion? So I used this little fellow. This is a solenoid. So solenoids are like tiny actuators. They're using electromagnets, and we can, when applying power, we can actually push or pull the actuator on demand. Using six solenoids, we can create a single Braille cell, since each Braille cell has six pins per position. And now, we can bring everything together. So we have to data model our software. So we have 6 pins per Braille cell. And as you can see, I'm using zeros and ones. Its symbol has zeros and ones in an array. So using ones, we're identifying raised pins, and using zeros, we're identifying idle pins. Unfortunately, Braille is not deterministic, so we have to actually create a map with the corresponding array representations for each letter, and a helper function that accepts a single character and returns the binary representation. A class, a cell class, will help us create an instance of each cell. So in the constructor, we are allocating the pins used by Johnny5, and using a private method called draw, we're gonna raise or pull the pins on demand. And finally, this is our main program. This is how our main program looks like. So we're gonna include Johnny5, we're gonna include the cell class, we're gonna instantiate a new board, and when the board is ready, we're gonna create a new instance of the cell class using the proper pins from the board, and finally, draw the letter A. And I can say that most of you are quite bored right now, so I will try to give you a live demo of my prototype. So let's break down this slide a bit. My entire application runs inside my browser using JavaScript and HTML. Here, as you can see, I have a live feed from my webcam. And this is the Braille cell attached on the device. So I have to be honest with you, each time I'm traveling with this device, I'm getting pretty anxious, so I just brought a single cell with me because I didn't want to get detained at the airport. So on the left side, as you can see, there's a live feed from my webcam. On the right side, this is a typeface called Braille Neue, which will give you a visual representation of the characters printed out. In the background, I'm running an HTTP node server that accepts incoming HTTP calls. And using the input on the top, I will write something, send it back to the server. The server will split the text into single characters, print them out on the device using an internal of 2 seconds. So cross your fingers and let's give it a try. Let's try to write something more meaningful rather than hello world, something like. Okay. Thank you. So apparently our prototype works, so let's bring up some results. As you could see, if you know where to find information about IoT, it's relatively simple to bring up the entire project using just a few lines of code and common hardware that you can buy from a hobby store. Also, the device itself is expandable, so we can create a device with one cell and expand it as far as we can get using the pins from the board. And finally, we can bring up a device with 12 Braille cells for just $40. But we're not done here yet. So currently, I'm working on the second version of the device. And during this process, I'm trying to improvise. I'm trying to create better design since this prototype is a bit clunky, and also get feedback from actual users. And for this purpose, I'm trying to integrate these tiny modules that are called microstepper motors. So these modules are controlling camera lenses, and using them, we can actually create a device that's more solid and more lightweight and also more accurate. And finally, using microstepper motors, I can make this we can make this device a lot cheaper, since we can salvage them from old cameras or recycle old components. Also, my entire goal is trying different modules, devices, or frameworks, so we can use this prototype and maybe create everything we want, just maybe attaching some sensors, I don't really know, but the idea is here. And for the past few years, I kept talking about this prototype. I had various different thoughts about maybe crowdfunding, trying crowdfunding the prototype, or maybe seeking for a fund. But instead, I'm just kindly asking for your help. So I think this is a great project for everyone that wants to get started with IoT. And the entire prototype is on GitHub, where you can find all the information about the schematics, code, and so on. And today, it's a really special day for me, because 2 years ago, in NodeConf 2017, I met Espruino. I had that wonderful workshop with the badge. So in early 2020, I'm planning of releasing the very first open source Braille printer that is powered by Espruino. And finally, if there is something that you can take away from this talk, is the fact that using the power from this community, you can do whatever you want, either hacking hardware, creating software, creating mobile applications, and so on. And I really think that this is our time, because we have the power, we have the assets, we have the tools, and who knows, maybe this is our time to shape up this world. Thank you so much.